So I really like these questions because they start off with just an equation of y is equal to, and then we need to differentiate that equation in order to find dy dt. And again, the whole idea here is that y and x are both functions of t. So we have y of t, we have x of t, and so whenever we differentiate, we're going to have to multiply by their respective derivatives. So here's what happens in this question. We start off with y is equal to x squared plus 3. Now, we are taking the derivative here with respect to t. And just like we have with implicit differentiation, whenever there is a mismatch between the variable that you're differentiating with respect to and the variable you're differentiating, so t and y, there's a mismatch there, we have to multiply by the derivative, and that is using the chain rule. So we talked about this in class, but again, anytime the variable you're differentiating with respect to do not match up, you've got to go through and multiply by y prime. So, or x prime or whatever prime you have your derivative. So here for d, when we take the derivative of y, we will just get dy dt. Now, we take the derivative of x squared, we get 2x, but again, there's a mismatch here between x and t, so we have to multiply it by dx dt. And then plus our 3 is just a standalone constant, so that goes to 0. Now, you can, if you want to, you can write down that dx dt is equal to x prime, but I personally feel very strongly it's nice to see this dt notation. So it's up to you what you want to do. If you want to convert it into prime notation, you can, but I'm going to kind of keep it as this dt notation for now, okay? All right, so we are trying to find dy dt, that's what we're trying to find, and then we have 2, they tell us that x is equal to 1. dx dt, they tell us at the very beginning of the problem is equal to 4. So that would give us that dy dt is equal to 8. And that's all there is to it. So we just differentiate, then plug in our known quantities, and we get the answer of 8.